Okay, so we ended the last video with just a recollection of the equation for a point slope formula, which we needed in order to create an equation for the two lines which represented the asymptotes. We said the equation for the point slope formula was y minus y1 is equal to m times x minus x1, where x1 and y1 we're going to use the center, and I corrected, I had an error here, it said parabola, but I meant hyperbola, so I changed it here. So the center of the hyperbola hk we're going to use for x1 and y1, and then of course we're going to use the slope from b and a in a different value. One's the reciprocal of the other, b over a for horizontal transverse axis and a over b for vertical transverse axis. And we said plus or minus to represent both the slope of the asymptote that is positive and the slope of the asymptote that is negative. All right, so in graphing hyperbolas, we're going to write in standard form as we've done to the right. And then we're going to, so this is standard form, we're going to identify the orientation. So the positive term is the x term, so that's the horizontal transverse axis. Now we're going to identify the coordinates for the center, find a, b, and c values, identify and plot the coordinates for the vertices, find the asymptotes, the foci, and then we're going to graph the hyperbola. Now we don't necessarily need to graph the foci, but we do need the vertices, we do need the asymptotes, we do need the center. So let's start. All right, so we have the center. Center is hk. Center is going to be 3, 2. And then I'm going to draw my transverse axis. It's a horizontal transverse axis, and I'm going to abbreviate my transverse axis as TA. Next step, I'm going to find the a, b, and c values. So going back to the equation, right, I have this equation, and, oops, I went too far. So I have this equation here, and I'm going to find my a value. Here's my a squared value. Here's my b squared value. So a is 7, b is 4, and then I'm going to use my formula c squared is equal to a squared plus b squared in order to find c. C ends up being the square root of 65. All right, so next thing I'm going to do is I'm going to identify and plot the coordinates for the vertices. I have two of them, co-vertices for the asymptotes, and then the two foci. Right, so we said a distance from the center along the transverse axis, which leaves me with 2 points, negative 4, 2, and 10, 2. Those are going to be the vertices of the two branches of the hyperbola. And then I'm going to take my b value from the vertices in a positive and negative direction vertically when I have a horizontal transverse axis. And then I'm going to use those 2 points to draw the line for the asymptotes. Now, then I'm going to use my center, 3, 2, and also my slope, which is plus or minus b over a, to create the two equations for the lines for the asymptotes. Y minus 2, c related to 2, plus or minus 4 over 7, so 4b over a, times x minus 3 here again, using the value for h. All right, and I have my equation, y minus 2 plus or minus 4 sevenths times x minus 3. And then I'm going to identify my foci. My foci are going to be 3 plus or minus square root of 65, 2. And I can label them in black here. They're a little bit, 3 plus square root of 65 is a little bit more than 10. It's approximately over 11 and a half or so. And so I've finished graphing here the foci. All right. So now I finished identifying the points, the major points, and constructing the branches constructing the asymptotes so that we can draw in the branches of the hyperbola. Right. So here we draw in the branches of the hyperbola. Here my branch goes through the vertex and again through the vertex, but never touches the asymptote. And so this is the last step in the process of drawing out a hyperbola. 2 branches, center, 2 foci, 2 vertices, and the 2 asymptotes. All right, this brings us to our third classwork problem. So I'm going to pause here while you write the problem down. Right, so now we're going to move on to writing equations of hyperbolas. So when we write an equation for a hyperbola, first we want to identify the orientation of the hyperbola, so the transverse axis, identify the coordinates for the center, these are the HK values, and then we can use the midpoint formula to find the midpoint if we have the foci or the vertices or the co-vertices, which are just the B values that are running along the axis that bisects the transverse axis, or runs through the center. Then we're going to determine the distance between the center and the vertices. This is the A value. Determine the distance between the center and the co-vertices. I put them in parentheses because hyperbolas don't have co-vertices, but we're going to use the same terminology to locate them, even though they're not part of the hyperbola. Again, they have the same terminology as ellipse, but there are no co-vertices, so to speak, in hyperbolas, but we're going to still use that B value, as mentioned before, to construct the asymptotes. And then if we're given coordinates for the focus, we may need to use the following equation to find the A and B values, or vice versa. And again, it's C squared is equal to A squared plus B squared. So you can take a moment and pause to write this down if you want, and we're going to go through these. Right, so here's a graph, and we're going to construct an equation from this graph. Center negative 3, 2, and then I have one of the vertices negative 3, 0, one of the foci negative 3, 6. There's also, of course, another vertex and another foci that are not identified, but we don't need those in order to construct our hyperbola. All right, so I'm going to give you the answer here. So first we're going to start with the center. Also the orientation is vertical, so y is going to be the positive term. So y minus k, y minus 2 squared minus x plus 3 squared. And then we're going to figure out 4 and 12 in just a moment. All right, so the A squared value is going to be the distance, is going to be 4, and that's going to be the distance from the center to the vertices. So center to the vertices in this case is going to be 2 units. So 2 squared here is going to be 4. And then the B squared value we're going to figure out by finding the C squared value. And the C value is going to be 4 or 16. So from negative 3, 6 to negative 3, 2 is 4 units. We square that to get the C squared value, that's 16. So now we have an equation 4 squared, C squared, is equal to 2 squared, A squared plus B squared. And we're going to solve for B squared. B squared ends up being equal to 12. Right, this brings us to our classwork 10.4.4. Recall we have one more classwork to do. I'm going to show you this and then leave this here for a moment for you. So you're going to generate an equation for this hyperbola based on these values. Okay, last thing we need to do is we're going to take general conic form. We're going to transition to standard form, and then we'll be done. All right, so standard form, we'll classify these two. Standard form is going to be what I've given to you, x minus h squared over a squared minus y minus k squared over b squared is equal to 1. General conic form, x squared minus y squared in this case, or it could be y squared minus x squared if it were a hyperbola with a vertical transverse axis. But in this case, we need to have, it can't be plus y squared. For plus y squared, it's either going to be a circle or an ellipse. So we have a positive and a negative squared term for the variables. And so general conic form is in this form here. So we're going to transition from the general conic form to standard form. All right, so I'm going to give you an equation. We're going to walk through. This is the same process of completing the square that we did before with ellipses, exactly the same. So first thing we're going to do is going to group the terms with x and y, move the constant term to the right side of the equation. Then we're going to distribute the common. So I've grouped 64x squared, 256x. And then the y terms, minus 9y squared, minus 36y, and then moved 356 to the other side of the equation. Now we're going to distribute out the common constant factors from the group terms, and we're going to set this up to complete the square. And then we're going to complete the square, and as I complete the square, I'm adding values in to the parentheses. So I need to, and in some cases, right, I'm multiplying that value in parentheses by some constant outside. So I need to account for the total value that I'm adding to the left-hand side or subtracting from the left-hand side to the right-hand side. So in the first grouping, I added 356, 64 times 4. I'm sorry, I added 256, excuse me, 64 times 4. And in the second grouping, I subtracted 36, negative 9 times 4. Right, so carrying that over, when I rewrite perfect squares as squared binomials, and then last step, we're going to divide by 576. So we're going to divide both sides by the constant term and simplify. 64 times x plus 2 squared over 576 minus 9 times y plus 2 squared over 576. As we divided both sides by 576, and we end up with this equation. All right. So that brings us to our last set of classwork for you to do, and that'll be it for today. 10.4.5, and I'm going to give you the equation here in general conic form, convert to standard form. So you can write this down. I'm going to pause for a moment and give you the next set of questions that you're going to fill out. Right, you're going to fill these out, and that's going to be it. All right, so please complete these. You have 5 classwork problems, as I mentioned. So again, this is the 5th. So you have, you are responsible for 10.4.1 through 10.4.5 for classwork, and you're going to submit that to me when you're done with this video. All right, that's it. Thanks very much for joining. Talk to you soon.